Okay, so I'm going to put together two lessons because, sorry, because some kids are like, Mr. Adler, I know that we have break, but I need a lot of math homework. So I'm going to teach two lessons, and you can do the work. You can do the work during the break, or you should work on it. You really should not be going any days without a little math, a little reading, a little. So let's talk about the law of sines. The law of sines. And this is another way of using trigonometry to relate the sides and angles of a triangle. So in the last class, we said that the area of any triangle. So let's look at this triangle. Let's say I have a triangle angle. This is angle C. And we use, B and A. But you know what? Let's just fill in the other sides here. Let me fill in the other sides. So this obviously is angle B because it's opposite B. And we're going to call this angle A, and then we're going to call this little side C. So first, when we did the area of a triangle, we had 1/2 AB sine C. But you know what I can do? I can take this triangle and rotate it and put D, I can rotate it so C is on the bottom. Let's rotate this. So our new triangle looks like this. So it's like A, B, C. What's great about this is just by rotating, you should have learned in geometry that rotation is an isometry. It doesn't change the area. And so rotation is an isometry. That means area doesn't change. So you might say, okay, Mr. Adler, well, therefore say this same triangle has an area of 1/2 AC sine B. And then you might say, Mr. Adler, we could rotate this again. If we filled in, this is A and this is C and that's a little bit. You can say, Mr. Adler, why don't we do it again? Why don't we rotate the triangle again? So the area doesn't change, but now this is A, this is B, this is C, and we see that the 1/2 BC sine of A is now the area of this triangle. Now, let's put this together. If we haven't changed the area, that means that these formulas are all equal to each other. So we can say 1/2 BC sine of A is equal to 1/2 AC sine of B is equal to 1/2 AB sine of C. So we have this long equation. The question is how do we simplify it? Well, we just divide everything by the same thing. For example, I would divide everything by 1/2. And as long as it's not zero, I can divide by my A, B, and C. So you know what? I'm going to divide everything by 1/2 ABC, 1/2 ABC, 1/2 ABC, and I start canceling out. Well, the 1/2 goes out with the 1/2, the BC goes out with the BC, and you have sine of A over A, right? What's going on over here? Well, the 1/2 goes out with the 1/2, the AC goes out with the AC, so you have sine of B over B, and you have in the last part over here, sine of C over C, and you have this really fascinating formula, and this is known as the law of sines. And the idea is the law of sines is the ratio of the sine of an angle over the opposite side. All these ratios are in proportion. The sine of A over A is equal to the sine of B over B is equal to the sine of C over C. And this allows us to solve some interesting problems. So let's get to it. Let's just do some problems over here. So how about we can take, so I can give you this example one, I can give you a triangle over here. I say that this angle is 60, this angle is 50, this angle is 60, the side opposite 50 is 9, and the side opposite 60 is x. Solve for x. And you say, okay, well, let's see what I have here. I have a bunch of angles. I have 50 opposite 9. I have the angle 60 opposite x. You know what? I'm going to use law of sines. The sine of 50 over 9 is equal to the sine of 60 over x. Stick that in NSolver exactly as you write it. Please remember, when you stick it in NSolver, these numbers have to go in parentheses. The angles have to go in parentheses. Also, please remember, at the top of your screen, you're using degrees. If you don't see DEG at the top of your calculator, either click for your GDC, click radian, and it'll turn into degrees, or send me an email. I'll tell you how to do it. The answer is 10.2. So x equals 10.2. Now, let's see. Oh, sometimes you might, so here's another problem. Example 2. So let's see. Let's take an obtuse triangle. Okay, this is 110 degrees. This is 20 degrees. This side is 18, and I ask you to find x. So you say, okay, I have two angles. I have two angles, and let me see what's going on here. So I know that 18 is opposite the 110 angle, but there's nothing opposite the x. I need this angle. What is this? Well, another thing I'm going to suggest is, when possible, fill in a lot of angles. You see that you have the 110 and the 20, so you say, oh, you know what? I know the sum of the angles of a triangle is 180, so let's figure that out. So it's 180 minus 130, which is equal to 50 degrees. You now have your 50-degree angle opposite x. And now you can set up the proportion for the law of sines. So you have let me use my black pen, sorry. We have sine of 110 over 18 is equal to the sine of 50 over x. Once again, please remember, when you're in the graphing calculator, put your angles inside of parentheses, and you would do like NSolve, open parentheses, comma, x. The answer should be 14.7. 14.7. Let's see. We have to be careful. We've spoken about this. Let's move on to an advanced topic for this class. It's not going to show up in SL applications, but it might show up in analysis. So in both examples, so I may give you this problem. Here's example 3. Once again, it's advanced. And so you might see, here's a triangle, and I say, let's see, I give you two sides, 11 and 8, and I give you an angle down here, 20 degrees, and I ask you to find angle, how about we call it, A. And you say, okay, that's no big problem, Mr. Adler, because, I have, 20 is opposite the 8, and angle A is opposite 11. I can use law of sines. If you recall from the last lesson, we have to be very careful because, first of all, you learn from your geometry class that side angle does not guarantee a unique triangle. So side angle does not guarantee a unique triangle. If you notice in these first two examples, I give you angle, side, angle, side, angle, side guaranteed. So, but that's fine. We can still put the equation together. And so you say, okay, Mr. Adler, the sine of A over 11 is equal to the sine of 20 over 8. And you might say, I can isolate sine of A, multiply both sides by 11. And so you have sine of A equals 11 divided by 8, sine of 20. Just for this example, because I'm not asking it, I figured this out actually. Let's see what this is as a decimal. It turns out the decimal representation is 0.470. And then you say, okay, I can do inverse sine or the inverse sine. So the angle is equal to the inverse sine of 0.47, and you get an answer. You get a nice answer of what do we get here? 28 degrees. 28. But in this situation, sine's a little tricky. We recall that this is an answer, but also 180 minus 28 degrees is also an answer. So once again, in this class, I'm only going to give you 2 angles and a side. In a more advanced class, you might get 2 sides and an angle, and you have to know about this last step. Okay, let's come back to the class. Now, for the break, or if you want to do it, I'll after the break, let's talk about something else. So I'm not going to derive the formula, but it turns out that, let's say you didn't get a bunch of angles. So we're going to talk about something called the law of cosines. So let's say you had given 2 sides and an included angle, or given 3 sides. We can use something that's called the law of cosines to either find the missing side, or we can use the law of cosines to find the missing angles, which is kind of cool. So the idea, once again, I'm not deriving the formula, it's a little advanced, but you do have to know it. So given, let's take a triangle. Let's take a triangle, and let's call our 2 sides A and B, and our included angle C. Okay? The idea is that little c, and the idea is that you're given an angle and an opposite side. That's what you're looking for. You're looking for an angle and its opposite side. The equation is c squared is equal to a squared plus b squared. Now it looks like the Pythagorean theorem, but it's not, because it's not we don't know if this is a right triangle, minus 2ab cosine C. As I said before, in the formula, the C and the C, this is what's given or omitted. Yeah, it's the side and the opposite angle. So this is the side and opposite angle. Now, these are just letters. I can write this. I can write, k squared equals e squared plus n squared minus 2en cosine of k. They're just letters, but the idea is, once again, this is the side and the opposite angle. Okay, let's do some examples. Here we go. Let's sit down. Let's take a triangle. Here's example. What are we up to? Example 4. Let's take a big triangle here, and we're told that the side is 5 and 8, and the included angle is 52 degrees. And I want to find the missing side. Well, this is a nice problem. You have 2 sides and the included angle. I'm missing the opposite side, so let's put this together. C squared equals 5 squared plus 8 squared minus 2 times 5 times 8 cosine of 52. Put this in NSolver. Please make sure that your cosine, the angle is within parentheses. This is the formula. You get the formula, and then that's what the answer is. The answer is 6.3. Now, here's the great thing about law of cosines. The great thing. So I might say to you, I might say to you, now, here's three sides of a triangle, 8, 9, 10, and I'm asking you to find, let's call this D, angle D. And I say, find angle D. And you say, okay, well, I have the formula. So I look at the formula. Looking at the formula. Well, let's just go back a second. What do you notice about it? Always look at your formulas, because it'll help you see what you need. So you say, okay, this formula, it requires 3 sides and an angle. Now, that doesn't work with the examples of the law of sines. I gave you a couple of angles and one side. That won't work here. But in an example where you have 3 sides, you can find that missing angle. Or if I give you 2 sides and an angle, you can find the missing side. So you say, you know what? I can use law of cosines. Let's say D is opposite the 9. And so the formula goes nice like this. So it's 9 squared equals 8 squared plus 10 squared. It looks a little different from Pythagoras' theorem, but that's fine. That 10 is not the main angle. We're not looking for the biggest angle. Minus 2 times 8 times 10 cosine of D. And you might say, Mr. Adler, are we running into the same problem that we ran into with sine? And the great thing about cosine is no. Oh, sorry about that. The great thing about cosine is that we don't have this 180 problem. We don't have the same problem. It's unique. So we love cosine. I love the law of cosines better than the law of sines. But because you don't run into this problem, so simply use n solver, and you get D is equal to, what's the answer? 58 degrees. And please remember, whatever variable you use here, when you use n solver, whatever variable, it's comma D, and also, that goes in the parentheses. Now, this is interesting because you can kind of explore, and so the idea here is you found 58. Now you can use the law of sines, the law of cosines, or the law of sines. Let's stick with the law of cosines to find all the other angles, and that's what's great. So the great thing about law of sines and cosines is now we have a method of finding the angles and the sides of triangles without having a right triangle. We've moved past that. The other great thing about the law of cosines is that we kind of explore, for example, let's take this right triangle that we know is 3, 4, 5, and I say prove using the law of cosines that this is 90 degrees. So let's call this E. So you say fine. E and 5, 5 is the hypotenuse. You think it's the hypotenuse. You know this is a Pythagorean triple. But let's see if the law of cosines validates that or verifies that for us. So you're like, fine. 5 squared equals 3 squared plus 4 squared minus 3 times 4. 2 times 3 times 4 times the cosine of E. Put it in an n solver, and you'll discover that E equals 90 degrees. Kind of cool. And you can do the same thing with an equilateral triangle. Put the sides in, like 7, 7, 7, go through the, find angle F. Angle F, cross here. So we have 7 squared equals 7 squared plus 7 squared minus 2 times 7 times 7. Cosine of F, and you'll discover that F equals 60 degrees. And that's what's great about these formulas. So once again, law of sines, 2 angles and a side. 2 angles and a side, and then law of cosines, you either have 2 sides and the included angle or 3 sides. Good. Work on the homework.